So what is half-life? So half-life is the time interval required by a radioactive element to disintegrate into half of its initial amount. So what do we mean by that? Let's understand through an example. Suppose you have one of the isotopes of hydrogen, that is 1s3 tritium, and it has got a half-life of around 12 years. So what will happen in 12 years is, if you have taken 100 grams of initial amount of tritium, so in the 12 years basically this will disintegrate into its natural stable elements, and it will be emitting some kind of radiation, and eventually 50 gram of tritium will be left behind. And this will not stop here. If you take another 12 years, that means another half-life, so it will disintegrate from 50 gram of tritium to 25 gram of tritium, with again some emission of radiation and at the same time some helium. So this goes on and on, but as the time passes the radioactivity decreases, simply because there is not much radioactive element left behind. So because radioactive element itself has a very unstable nuclei, it keeps disintegrating into a stable nuclei, and at the same time, as the name suggests, radioactive, so that means it keeps emitting some form of radiation, and these radiations could be comprised of alpha, beta or gamma. Now in the laboratory setup you can calculate the amount of this radiation by Geiger-Müller counter, but if you want to calculate half-life of any radioactive element, there is a formula which is there on the screen. And quite interestingly, half-life can vary from fraction of second to billions of years. Usually half-life does not depend upon the initial amount of the isotope or radioactive element, but if the reaction is 0th order or 2nd order, then it does depend upon the initial amount of the isotope. On contrary to half-life we often talk in chemistry, there is also half-life in biological system. For example, if there is a drug which you have given to the human body, so after how much time the efficacy of the drug is half of its initial time, that is also half-life there. But that's a different story altogether.